Hi everyone, welcome to datascience.works, and in the machine learning series today we are going to discuss about naive-Bayes classifier. So are you guys ready? So let's get started. So now I'm going to show you how we can use this kind of classifier. So the topic for today is naive-Bayes classifier. So let's discuss the agenda first. That is, first is we are going to introduction to conditional probability and the Bayes theorem. Next, we are going to understand the naive-Bayes classifiers. And we will be discussing about the assumptions of the naive-Bayes algorithm. Next is the application of naive-Bayes, where you can actually utilize this algorithm on real-world datasets. And the final step is coding, that is, we are going to implement in Python. So this is the agenda for today. So let's get started with the first, that is introduction to conditional probability and the Bayes theorem. So conditional probability, as the name is suggesting, like we are going to calculate the probability of an event given that some other event has already been occurred, right? So the notation for this will be probability of A by B, where B is the event that has already been happened, and we are interested in calculating the probability of A, the event A. So the formula, we can see, is probability A by B is probability A intersection B divided by probability of B. So as you can see here also, for example, this is event A, this is event B, and this is your A intersection B divided by the total probability of the B event, right? So this was about conditional probability. Next is the Bayes theorem. So Bayes theorem is basically tell us how to calculate the conditional probabilities, right? It gives us the theorem. So PA by B, which is equal to PB by A, multiply by PA divided by PB. So what does this equation actually mean? So let's decode that. So PA by B is simply means that we calculated now, right? So B is the event that already happened, and we are interested in calculating the probability of A. So it's a posteriori probability. We called it. Next is, what is this? PB by A is your likelihood, right? Because now we are calculating PB by A, right? Next is PA. What is the probability of A? That is known as your prior probability. Okay, and next is the probability of B. And this theorem, as we all know, because B is, in the denominator, so A and B events, and probability of B should not be equal to 0. So this is the theorem that Bayes tell about. Okay, next is, let's understand this with the help of an example, because I think it will be more clear to you. So for example, bag 1 is containing 2 white and 4 black balls, and bag 2 contains 3 white and 6 black balls. Okay, now what I'm doing is I'm drawing one ball at a random, and it's found to be white. So it is, I have drawn one ball and it is white. So I am now interested in calculating the probability that a ball was drawn from bag 2. So we have bag 1 and bag 2, and I randomly pick ball and it was white, and I want to calculate like what is the probability that it was drawn from bag 2. So this kind of thing, what we can utilize simple the naive-Bayes theorem that I told you this about. So now we will be defining probability of A and the A and the B events, and we'll be decoding that with the help of this equation. So let's see how. So we are interested in calculating that the ball is white because we know the ball is found to be white. So this event has already been occurred. We are interested in finding the probability that it is taken from bag 2. So now the event is A. And this is the formula. If you can easily decode it, divide by the total probability from bag 1 also and bag 2 also. So this equation you can decode. So this is one of the example that I shown you where you can actually utilize. I think you have utilized Bayes theorem in almost some of the probability examples, right? So this was about to understand the naive-Bayes equation, how to apply. Next is the topic is today is naive-Bayes classifier. So what does it actually mean? So it's a family of classification algorithms that are based on the Bayes theorem. So Bayes theorem we discussed, and classification algorithm we already know. So it's a classification algorithm that are based on the Bayes theorem. Next is it is using the probabilistic approach. So hence we can quickly predict. So it is faster. Why? Because we just have to calculate some, calculations, and we can easily do that. Next is how many types, different kind of classifiers are there. So we have Gaussian naive-Bayes. Next we have Bernoulli naive-Bayes. Next we have multinomial naive-Bayes. I will be discussing each and every one in the next slides, so you can have a basic understanding of these. What does it actually mean? So let's start. So first we will be going to discuss is the Gaussian naive-Bayes. So in Gaussian naive-Bayes, for each feature, for example, we have a data set, right? In the data set, we have multiple columns. So in the columns, we have values that are continuous, but how the values are distributed. So this is Gaussian naive-Bayes is telling that the continuous values are distributed according to a Gaussian distribution, or we can say normal distribution. So we all know. So if you don't know, like, what is a normal distribution? So normal distribution is basically a bell-shaped curve that has mean equal to mode is equal to median, right? So I'll show you how the curve look like. Like, this is the normal distribution. So the values are distributed according to this distribution in case of Gaussian naive-Bayes. Next is Bernoulli naive-Bayes. So here your features. So you have a data set. So assume, like in mind, we have a data set, and what kind of values we can actually take in each of one of them. So here features are your independent Boolean variables. Boolean variables means simply 0 and 1. So in Bernoulli naive-Bayes, we have these values. Next is the multinomial naive-Bayes. So here basically the samples are representing your frequencies. Frequencies is basically how many times it is occurring. So when can you, it will be useful. So for example, in text classification, if you do, so you have a sentence, and each word, so you generate we have vocabulary, and then each word is repeating how many times, right? So in that case, in these kind of application, text classification, we can utilize multinomial naive-Bayes, because here the samples are representing your frequencies, like how many times this word is occurring, right? And you can utilize your bag of words model, or TF-IDF, for generating the frequencies, right? Next is what are the assumptions, because this algorithm have some assumptions. So what are this? So and this is one of the most important slide for today's session. So what are the assumptions? So naive-Bayes considers features and your predictors to be independent. So you have multiple features and it considers them all to be independent. So what does independent mean then? So two events are called independent when the occurrence of one event, when the occurrence of one event does not have any effect on the occurrence of other event. So both are independent, can occur, right? So naive-Bayes consider each feature will be contributing equally, and it will not have any impact on the other feature, right? So every feature, for example, you might be having, say, 4 columns in the data set, and you have 3 columns, your features, and next 4th column is your target. So each of one of the 3 features is independent, and each one will be having equal contribution in the naive-Bayes. So these are 2 assumptions that we have to take care while applying this algorithm. I hope I made it clear. So next question that is coming, popping into your mind is, how do we actually apply naive-Bayes algorithm on real world data sets, right? So I have shown you, the probability, the naive-Bayes theorem equation. So I have told you, like, A, probability of A by B is your likelihood multiplied by prior, okay, divided by probability of B event. In real world data sets, we instead of just one feature, we can have many features. So if you visualize, I mean, if you can see the data set, so there are multiple columns in your data set, okay, that are contributing to the, I mean, your data set. And so here, so we have x1, x2 up to xn. So these are your multiple features and you are interested in calculating the target probability. So for example, you have some class A and class B. Now, so here we are also applying the same naive-Bayes algorithm. So if I mean, scroll back to, so this was the algorithm, right? So here it is also the same algorithm, but let's see how we are going to apply on the real world data sets. So these are your features. And as I already told in the previous slide, that naive-Bayes algorithm considers each feature to be independent. So it's, I mean, y is equal to k, that is your x1. Now y is equal to k, that is your label, and x2 up to xn. And these are your individual probabilities. Multiply by probability, this is your prior probability, and these are your probability of B. I mean, this B is now consisting of multiple features. So this is the formula, and you can utilize, and each feature will be independent. So that's how we apply naive-Bayes algorithm on real world datasets. So I hope it made it clear, and you are able to map so from the naive-Bayes theorem to this equation. Okay. Next is what are the applications of naive-Bayes. So let's discuss. So first one is the spam filtering. So you can utilize this algorithm to for example, email classifications, whether it is a spam or yes or no. So you can utilize this. Next is the sentiment analysis you can utilize. Next, I discussed text classification, like using multinomial naive-Bayes, how many times a word is repeating, and these kind of classification, text classification applications, you can actually utilize naive-Bayes algorithm. And what is the variant you are going to use is the multinomial naive-Bayes. Next is the, in case of recommendation systems, we can also utilize naive-Bayes. So these were some of the applications that you can actually utilize your algorithm and build each kind of application to have a better understanding of naive-Bayes algorithm. Next is you might be come across this question. I mean, people ask you in interviews or why naive-Bayes is called so naive. So it assumes feature to be independent, right? So it is assuming like you have a data set and you have multiple features, and it is assuming that each feature is independent, right? So this, I mean, assumption is unrealistic for real world data sets, right? Because feature might be dependent. So in most of the cases, they are dependent on each other, right? So, but naive-Bayes assumes that each feature is independent. So that's why it is called so naive. So this is the question that people might ask you in interviews. So keep note of it. Next is the coding. We came to the last slide of our today's session. So in coding, we are going to implement, I mean, the naive-Bayes classification on a simple data set from scratch. So now it's time for coding. So coding, I just always use the same steps, 4 simple steps. So first one is get the data first. Okay. Next is create the model. Third one is the fit the model. And fourth is get predictions from your model. So now I'm going to Google Collaboratory, where I have created this for you. Also, this was my importing the library, so I can zoom it. Yeah. So importing the library. So what I have done is imported the Gaussian naive-Bayes. So for today's session, I will be implementing Gaussian naive-Bayes, right? So you have multiple variant that we did, right? Multinomial or Bernoulli. So based on your kind of application and your data set, you can utilize this algorithm. And from this sklearn.naive-Bayes, I am importing this. Next is I'm generating some random data. So it's a random data. Why I'm doing for this is because it is faster and you can just have a view like how to apply these kind of things. So it's your input feature X is your array of inputs, right? And output is your classes. So one, I have taken two labels. One is belonging to one, and second class is two, right? Next is the creating the model and fitting on the data. So what I have done simply is initialize my Gaussian naive Bayes because I have imported it initially from here. And now I have to fit this on my this input feature X and your output feature, that is your target that we are interested in finding. And next is the predictions. So in predictions, I have just passed my input and I called my classifier that I trained on to predict on my. So I get 2. I got 2, so it belongs to class 2. So this observations belong to class 2. So this was all about naive-Bayes classifier. You can utilize on a larger data set depending on your, multiple columns you might be having. So you have to do some pre-processing, right? And then you can utilize this. So I'll be discussing the pre-processing techniques and how do you pre-process and clean your data sets in coming slides. But for today's session, I have taken a very simple, kind of example to demonstrate and for faster computation. So I hope you enjoyed. So congratulations, you completed the naive-Bayes classifier, and I hope I made it clear. So that's all for now. Thank you, everyone. Happy learning.